All right, welcome to Unit 7, Day 1. We are going to take some notes on area and perimeter today, so make sure you have notebook paper out and you are following along. If at any point you need to pause the video, just do so, and you will be ready to go when this video is done. Unit 7, we're going to be talking about surface area and volume, and so we're going to get to talking about three-dimensional figures, meaning figures that exist in three-dimensional space, like not just flat surfaces, but this would be an example of what we call a prism, P-R-I-S-M, and it has a volume we could measure because it's three-dimensional. It also has a surface area, but we're not going to be starting with that. We want to take this first lesson and make sure we know how to find the area of certain figures, both what we consider to be simple figures like polygons and circles, but also finding area and perimeter of what we call composite figures, which we'll get to in a little bit. So the first thing I want us to do is to write down some formulas for area and perimeter. Okay, and we're going to start off with some basic shapes. If we have a triangle, any triangle, the area formula is base times height divided by 2. Or you might also see it called 1/2 base times height. It might look like this. But really, we're going to think of it like this. For any triangle, what I want you to remember is that base and height are perpendicular. That means this symbol means perpendicular. They form a right angle. So this would be my height if this is my base. And then we're going to move on to parallelograms. Now, parallelograms also include rectangles. So whether it looks like this or maybe it's all right angles. Sorry, my line's kind of wavy. There we go. If they're all right angles, it works out to be the same formula. Area is just base times height, or length times width. You might have seen it length times width, but we're going to use base times height here. That's in any parallelogram or rectangle. These are triangles. If you want to write down their names underneath, you can. In any rectangle or parallelogram, base times height is your area formula. But we also have other quadrilaterals called trapezoids. Now, it doesn't have to be isosceles to be a trapezoid. In any trapezoid, we have two parallel sides called bases. This would be base 1, this is base 2. And then we have a height measurement that is the distance between those bases. So the area formula for any trapezoid is the sum of the bases, base 1 plus base 2, all times the height, all divided by 2. And the way this works out, this base 1 plus base 2 over 2 is like finding the average of the height, the average of the bases, times the height. But that's your formula for area of a trapezoid. Those are our polygon formulas we need to know, but then we also have formulas for circles that we just finished testing over. So if I have a circle with a given radius, the area formula for a circle is pi r squared. But in this unit, you're also going to notice that we will use some semicircles, or half circles. Well, the area formula for that is a full circle cut in half, divided by 2. Now notice that I haven't really said anything about perimeter, and that's because in perimeter, there isn't really a formula you could use. You could use a formula for rectangles, but really perimeter is very simple. To find the perimeter, you simply find the sum of all sides. Sum means we're going to add all the sides. If we are trying to find the sum of sides of a figure, and one of the sides uses part of a circle like this, a semicircle, we would take the circumference, which is 2 pi r, and cut it in half, divide by 2. Now you might notice that if I have 2 on top and 2 on bottom, they would cancel, so I could just call this pi times radius. But that's only if we're using half of a circle, not including that bottom edge. So those are your formulas that are going to be useful today in our lesson. We are going to now take a look at working on some examples of composite figures. So I'm going to show you how to find the area and perimeter of a composite figure. So in order to do that, I'm going to have you draw this out. On the assignment that I give you and on the notes from now on in this unit, you will not have to draw these yourself. Don't freak out about having to draw these. Use the lines on your paper as a guide. Try to make yours look like mine. Okay, so I'm going to pause the video so I can draw this for you, and then I'll show you what it should look like. Okay, this should be your drawing for example 1. Okay, now you will need to pause the video right now so you can copy this down and make sure you have what it looks like. All right, everything that looks to be parallel lines we're going to assume are parallel. Everything that looks like a right angle we're going to assume is a right angle for this. Okay, if you need more time, again, make sure you pause to copy this down. When you're ready, go ahead and proceed with the video. So what we're going to do here, we're going to find our area first. Okay, the area of any composite figure, the word composite means composed of or put together. So we're going to break this into its most simple shapes. I've already put the dotted lines for you here to show that this is really just a rectangle with a triangle above and a triangle below. So the area could be broken into this formula. Area of the rectangle plus area of the triangle plus the area of the other triangle. Okay? Area of a rectangle is just base times height. And then the two triangles are base times height divided by 2. It's really important that you keep writing these formulas down until you are more comfortable working with them from memory. So let's just figure out what the base and height are of our figures. And this may not be drawn to scale, meaning the measurements might look longer or shorter than they actually are. For the rectangle, base and height are the length and width. Now, the base of your rectangle extends all the way past to over here. So it's 15, but it's also this 5 for this part of the triangle. So the base of your rectangle is actually 20. And the height of your rectangle from here to here is 10. Okay? Kind of running out of room, so I'm going to come down a line. The base and height of your triangles, you'll notice that these sides are all the same, so because they're marked congruent, so that's 5, that's 5, and that's 5. So base and height of your triangle, remember, are perpendicular measurements. They're perpendicular to one another. So base and height are both 5. Not plus, I'm sorry, 5 times 5 divided by 2. But there are 2 of those. So I'm just going to start simplifying things. 20 times 10 is 200. 5 times 5 divided by 2 is 12.5, because 5 times 5 is 25. And then this other 5 times 5 divided by 2 is another 12.5. So when I combine these, 20 plus 12.5 plus 12.5, I should get 225. And I would be in square units. If I gave you the unit of measure, I would expect you to write it down. But that's all we have to write for the area. To find the perimeter, we're simply going to add up all the sides. We do not include dotted lines that are in the interior of a figure because they're not part of the outside edge. They're not part of the perimeter. So I'm not going to include this 5 and this 5 in my perimeter. But to find the perimeter, I'm just going to start adding the sides. So I've got a 15 here, plus a 15 here. Remember, this side over here is also 15, plus this other 15. So there are 4 15s I'm adding. And I'm just going to kind of wrap these around here like this. But then I also have these slanted sides that I have to add in. In order to find these, remember, these would be sides of a right triangle. And in fact, they are each the hypotenuse of the right triangle, C. Remember that we know a squared plus b squared equals c squared. The Pythagorean Theorem works for any right triangle. So I'm going to plug those in here. 5 squared plus 5 squared, those are both a and b because they're the legs, is equal to c squared. Okay, I'm kind of running out of room. You might be on your paper too, that's okay. Come wherever you have room. 5 squared and 5 squared are each 25. 25 plus 25 is 50. So c squared equals 50. that means C is the square root of 50. Okay, so I have two of those. I'm going to leave it written as the square root of 50 for my problem. I have square root of 50 here and square root of 50 here. I'm going to plug those into the calculator and then add 15, 15, 15, and 15. Or you can combine all of these 15s and just get 60. Okay, so if I wanted to simplify this on paper, I have a 60 plus 2 square roots of 50. And so I would put that in the calculator, and when I do, it is approximately 74.14 units of measure. And that's how we find perimeter. You simply add up all the sides. But don't forget things like the Pythagorean Theorem to help you find missing pieces. Okay, we are going to go ahead and do one more example, and so I'm going to turn the page here in a minute, and I will have another example drawn for you. At that time, you'll need to pause the video so you can copy that down, and we will find perimeter and area of that figure also. Okay, let's get ready to go to example 2. Alright, you're going to see in this example, and again, pause the video here so you can copy this down. Alright, I'm assuming you have this copy down and are ready to go. In this example, we have several figures put together, and we want to find the area and perimeter of this one figure. What I want you to see is how they have separated this figure. I've already put the dotted line for you here to show that this is a triangle on the side. And if I look in the center here and kind of put another dotted line here, that becomes a rectangle that is 7 by this total height. That makes this a semicircle. But I want you to realize the radius of that semicircle is half of this full length. Well, if this is congruent to this and this is a rectangle, that means this is 5, and that whole thing is 10. So that means the diameter of your semicircle is 5, so the radius is half of that, which would be 2.5. So when I go to use my area for a semicircle, I'm going to use that radius. Okay? And when I use my formula for the circumference, or half of my circumference of a full circle, I'm going to use that diameter or that radius. So let's find the area first. Okay? Our area is simply going to be the area of the semicircle plus the area of the rectangle plus the area of the triangle. For a semicircle, I'm going to do pi r squared and cut it in half, divide by 2. For the rectangle, I'm just going to do base times height. And for the triangle, I do base times height divided by 2. And I add those results. So let's plug this in. R is 2.5, as I've already stated, so it's pi times 2.5 squared, and I'm going to divide that by 2, plus the base of your rectangle, I'm going to call this horizontal measure, that'd be 7. The height of my rectangle is from here all the way to here, which I've told you is 10. And then to fill in this formula, the base of your triangle, I'm going to call 12. The height of your triangle is from here to here, which is right across from this 5, so we can know that that is 5. And that's all over 2. And so I start to simplify this one step at a time. Okay, this I'm going to simplify for you. 2.5 squared is 6.25, and I'm going to divide that by 2, which gives me 3.125 pi, and then I'll multiply with pi in my calculator. But 7 times 10 is 70, and over here 12 times 5, okay, 12 times 5 is 60, but I have to divide that by 2, so that's 30. So these like terms are easy to combine, that's 100, but then I have my plus 3.125 pi. So I would put it in the calculator exactly like this. I would multiply first, then add 100, and when I do that, I get approximately 109.82 units of measure for the area. Okay, now to find the perimeter, I'm just going to start adding up the sides. Now, this is going to be a little tricky, but we'll get to that in a second. So I'm going to add a 7 plus a 5 plus this slanted side here. Now, to find that slanted side, we have to use Pythagorean Theorem again.